In this video we will solve some problems with parallelograms, and we're trying to find the values of the variables here. Now it's super tempting just to say, oh, 16 must be equal to 3x plus 4 and 56 must be equal to y minus 60 because we want it to be like that, but we can't just willy-nilly assume stuff is true. So let's try to reason and explain our way through some of these and see if in fact they are true. And if they are true, then we'll try to find a way to prove that they are true. So I'll name this parallelogram A, B, C, D. And because it's a parallelogram, we know that the opposite sides here are parallel to each other. Okay. And I definitely want to show that these opposite sides are also congruent to each other. So we're going to employ a nice little trick where we draw this diagonal across here, and in doing so what we do is we turn the side lengths into transversals, so we can say that this angle up here ABD and this angle down here must be congruent to each other. So ABD must be congruent to triangle CDB because they are alternate interior angles. And you have parallel lines. So alternate interior angles theorem. And similarly, let's change up the colors just a little bit here. ADB and CBD are also congruent to each other. For the exact same reason as mentioned above. And so we have an angle here. We have yet another angle here, and we have the side that's joining them in the middle. So BD is congruent to DB really by the reflexive property. It's the same thing, and so that gives us a side. So when you read that all together, we can say that triangle ABD, is congruent to triangle CDB by angle side angle. So you have two angles that are congruent joined together by a common side. Now, because they are congruent, the triangles, because the triangles are congruent, we can now say that the angles are congruent. So angle C must be congruent to angle A by corresponding parts of congruent triangles are congruent. So this angle down here and this angle up here are congruent, and because that's true, we can also say the opposite sides. So CD and AB are congruent, and BC and AD are congruent as well. So altogether we can let me write this down. AB must be congruent to CD, also by CPCTC, and AD must also be congruent to CB. So altogether, this is a nice, wonderful theorem, and so we're going to call this theorem the OSA, the opposite sides and angle theorem. Okay, that basically says in a parallelogram, the opposite sides and the opposite angles are congruent to each other. So with that in mind, we can go back to the problem and solve. Now we can say definitively that 16 is equal to 3x plus 4. Subtract 4 from both sides, you get 12. Divide by 3, you get x is equal to 4. Similarly, we can do the same thing with the angles. Y minus 60 is equal to 56. Add 60 to both sides, and we get that y is equal to 116 degrees. Okay. So there you have it. Reasoning through the problem gives us a new theorem. Let me name this officially. Opposite sides and angle theorem, or we'll abbreviate it OSA for opposite sides and angles theorem. And using it, we can solve problems with parallelograms quite quickly. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.